Welcome, everyone. Today, we are embarking on an exciting journey into the heart of enterprise AI with Snowflake Cortex LLMs. Let us get started and unlock the power of fully managed AI directly within your data cloud. Let us kick things off by defining exactly what Snowflake Cortex LLMs are. In the past, applying generative AI to your enterprise data meant extracting that data, moving it across the network to an external AI provider, and then bringing the results back. This created a massive headache for security, compliance, and data engineering teams. Cortex LLMs completely flip this paradigm. By providing fully managed, industry-leading large language models directly inside the Snowflake data cloud, Cortex brings the AI directly to your data. Whether you need to generate text, summarize massive documents, or analyze sentiment, you can now do it all using the SQL or Python skills you already possess. There is no infrastructure to provision, no complex API keys to manage across different teams, and most importantly, no data movement. This is the foundation of secure, scalable enterprise AI, allowing you to seamlessly integrate advanced machine learning capabilities into your existing data pipelines. Take a look at the flowchart on your screen. It beautifully illustrates the simplicity of the Cortex architecture. On the far left, we start with your enterprise data already residing securely in Snowflake. Notice how the arrows flow directly into Snowflake Cortex without ever crossing an external network boundary. Inside Cortex, your data interacts with two main branches, pre-built LLM functions for specific tasks like summarization and general-purpose LLMs for open-ended text generation. Both of these powerful AI engines process your data natively and output actionable insights on the right. This diagram highlights the core value proposition of Cortex, a closed-loop, highly secure ecosystem where your data never has to leave its governed environment to benefit from state-of-the-art artificial intelligence. Now that we know what Cortex is, we must answer a critical question. Why should enterprise architects and data leaders choose Cortex over external LLM APIs? The answer lies fundamentally in security and governance. When you utilize Snowflake Cortex, your prompts, your context, and your generated responses never leave the Snowflake governance perimeter. Snowflake guarantees that your proprietary data is never used to train or fine-tune models that are made available to the broader public. Furthermore, Cortex deeply integrates with Snowflake's role-based access control, or RBAC. If an analyst queries an LLM against a specific table, Cortex automatically enforces all underlying security policies, including row-level security and dynamic data masking. From an architectural standpoint, you are executing these heavy AI workloads using Snowflake's serverless compute. You do not need to worry about provisioning GPUs or managing cluster uptime. You simply pay for the tokens you process, making it highly cost-effective and strictly governed. This top-down diagram breaks down the rigorous security gauntlet every Cortex LLM request must pass through. At the top, the user query is initiated. Immediately, it hits the role-based access control node. The system asks a binary question: is this user authorized to see the underlying data? If the answer is no, it routes directly to access denied. If yes, the request proceeds into the Cortex LLM engine. But the security checks do not stop there. Before the final output is generated, the system applies any existing data masking policies, ensuring that personally identifiable information or sensitive metrics are redacted or obfuscated. Finally, the user receives a secure AI response at the bottom. This visual perfectly captures how Cortex ensures AI is never a backdoor around your existing data governance rules. One of the most powerful aspects of Snowflake Cortex is that it does not lock you into a single AI provider. Let's explore the Cortex model ecosystem. Snowflake has partnered with the biggest names in AI to host a curated suite of state-of-the-art foundational models directly inside your data cloud. You have access to models from Anthropic like Claude 3.5 Sonnet, Meta's Llama 3.1 and 3.3 families, Mistral's large and 7B models, as well as select models from OpenAI and DeepSeek. Why so many choices? Because in enterprise AI, one size does not fit all. For simple classification or translation tasks, a smaller, ultra-fast model like Llama 3.18b is incredibly cost-effective and provides low latency. However, for complex reasoning, multi-step agentic workflows, or heavy coding tasks, you can instantly scale up to a frontier model like Claude 3.7 Sonnet or Mistral Large 2. You simply specify the model name as a string in your function call, giving you ultimate flexibility to balance cost, speed, and intelligence. Let us walk through this decision tree diagram, which illustrates how you should select models in Cortex. On the left, we begin with task complexity. As a developer, you evaluate your use case and move to the Choose Tier decision node. If your task requires complex, multi-step logic, you follow the top path to large frontier models like Claude 3.7. If you need a solid balance of cost and performance, you take the middle path to medium models like Llama 7DB. And for bulk, simple tasks like massive sentiment tagging, you take the bottom path to small, lightning-fast models. All three of these paths eventually converge into the AI Complete Execution node. This diagram is a fantastic mental model for your daily workflow, reminding you that optimizing your AI pipeline is as simple as routing your query to the correct weight class of model. Now, let us talk about implementation. How do you actually use these models? Snowflake has made this incredibly intuitive by exposing Cortex LLMs through both native SQL functions and the SnowPark Python API. For many common workloads, Snowflake provides task-specific functions. If you need to translate text, extract sentiment, or summarize a document, you can simply use functions like AI Translate or AI Sentiment directly in your select statements. Imagine updating millions of rows of customer reviews with sentiment scores using a single SQL command. For more custom, open-ended tasks, you use the AI Complete function, passing in your prompt and your chosen model. But SQL is not the only way. For data scientists and application developers, the Snowflake.Cortex module in Python provides a seamless, programmatic interface. You can wrap these LLM calls inside SnowPark Python data frames, integrating them beautifully into complex data engineering pipelines, CI/CD workflows, and machine learning architectures. This flow diagram clearly maps out the dual pathways developers can take when accessing Cortex. From the developer choice node at the top, we split into the SQL interface on the left and the Python API on the right. Following the SQL path, you can see examples of direct function calls like AI Sentiment and AI Complete, which natively feed into batch analytics for massive datasets. On the right side, the Python API path shows a standard import statement, which then routes into application backends and pipelines. By looking at this diagram, learners can instantly perceive that Cortex does not force you to learn a proprietary new language. It seamlessly adapts to whether you are a data analyst writing declarative queries or a data engineer writing imperative Python code. As we dive deeper into advanced capabilities, we must discuss one of the most critical features for enterprise pipelines, structured outputs. By nature, LLMs output unstructured text. If you ask an LLM to extract a customer's name and age, it might reply, "The customer's name is John and his age is 35. That is great for a human, but terrible for a database. Historically, engineers had to write brittle regular expressions to parse this text. With Cortex AI Complete, you can use the response format parameter to strictly enforce a JSON schema. You tell the model exactly what keys and data types you require, and the model is mathematically constrained to output a valid JSON object matching that exact schema. This completely eliminates hallucinated formatting and downstream pipeline breaks. Structured outputs transform an LLM from a simple chatbot into a highly reliable, deterministic data extraction engine, making it safe to wire AI directly into your core business processes. Look closely at this diagram mapping out the structured output pipeline. Notice that the AI Complete node in the center receives two distinct inputs, the raw unstructured text on the top left and the strict JSON schema definition on the bottom left. It is the combination of these two inputs that forces the LLM to synthesize the data cleanly. The output arrow leads directly to a valid JSON output node, completely bypassing any messy string manipulation. From there, the clean JSON is easily parsed into Snowflake columns, which securely and reliably feeds into your downstream BI dashboards. This visualization proves how structured outputs bridge the gap between messy human language and the rigid requirements of enterprise data engineering. Our next deep dive takes us to the cutting edge of customized AI, Snowflake Cortex fine-tuning. Sometimes, prompt engineering and context injection are just not enough. You might have highly specialized industry jargon, unique SQL dialects, or a specific brand voice that off-the-shelf models struggle to replicate. Cortex fine-tuning allows you to customize models like Llama 3 or Mistral using your own proprietary datasets. Behind the scenes, Snowflake utilizes parameter-efficient fine-tuning, or PFT. Instead of retraining billions of parameters from scratch, which costs a fortune, PFT trains a lightweight adapter that sits on top of the base model. You simply call the fine-tune function, point it to a table containing your prompt and completion examples, and Snowflake handles the distributed training. Once finished, you receive a custom model endpoint that operates securely within your account. This delivers bespoke AI accuracy at a fraction of the traditional cost, directly where your training data already lives. This flow diagram deconstructs the Cortex fine-tuning lifecycle. Starting at the top, we have our curated training data pairs of prompts and desired completions. This data, alongside the chosen base model, flows into the fine-tune function. The system then executes the PFD training process, represented as the central processing hub. Once the compute-intensive work is securely completed by Snowflake serverless GPUs, it outputs your custom fine-tuned model. Crucially, the final arrow shows this custom model flowing directly into the standard AI complete inference node. This visually reinforces to the learner that using your newly minted, highly specialized model is exactly as easy as using any of the standard, out-of-the-box foundational models. Let us tie all these concepts together with a powerful, real-time use case: automated support ticket analysis. Imagine your enterprise receives tens of thousands of support tickets daily across a dozen languages. Manually triaging these is slow, expensive, and leads to customer churn. With Cortex LLMs, we can build a fully automated, intelligent pipeline inside Snowflake. As tickets stream in, we first apply the AI translate function to standardize everything into English. Next, we run the AI sentiment function. Any ticket scoring a highly negative sentiment is immediately routed to a specialized retention team. Finally, we use the AI complete function equipped with structured JSON outputs to read the text and cleanly extract the specific product name and the root cause category. This pipeline operates asynchronously, processing massive volumes of unstructured text and transforming it into clean, structured analytics that update your executive BI dashboards in near real time. This is the true ROI of Cortex. Follow the journey of a support ticket through this pipeline diagram. On the left, multilingual tickets enter the system and immediately hit AI translate to normalize the language. The data then flows into AI sentiment. At the decision diamond, we check if the sentiment is highly negative. If yes, it branches up to alert a human agent for urgent care. If no, it continues to the AI complete structured output node. Here, the unstructured text is cleanly transformed into the extract product and category node, which subsequently feeds directly into the executive BI dashboard on the far right. This diagram brilliantly illustrates how multiple Cortex functions can be chained together to create sophisticated, autonomous business processes without ever moving data outside the cloud. As we wrap up our training, we must touch on governance and cost management. Snowflake ensures you maintain tight control over your AI spend. First, AI features are opt-in. An administrator must explicitly grant the Cortex user database role to your analysts or service accounts. When it comes to billing, you are charged based on the number of tokens processed. To monitor this, Snowflake provides system views like Cortex functions usage history, allowing you to track exactly which models and queries are driving your costs. A major best practice is to right-size your models, use cost-efficient models like Llama 8B for bulk extractions, and reserve heavy models like Claude 3.7 for complex reasoning. By mastering these tools, you are transforming how your organization leverages data. You have now seen how Cortex democratizes AI. To master these concepts, I invite you to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and exclusive interview guides. Thank you for watching and happy building. Our final diagram outlines the administrative lifecycle of Cortex. Starting at the top, the account admin is responsible for the initial security gate, choosing to grant the Cortex user role. Once granted, the data engineer or analyst can safely execute Cortex functions. This execution directly drives token-based billing. However, the loop does not end there. Administrators can monitor this spend via the Cortex function's usage history view. This monitoring step feeds back into the crucial optimization phase at the bottom, where teams optimize model choice and spend, ensuring maximum AI ROI. This visual perfectly summarizes the governed, transparent, and manageable nature of enterprise AI on Snowflake.